A computational fluid dynamics engineer spends a lot of time in doing something called meshing. Won't it be good if we can save the time so that the person can watch more TV series on Netflix? Well, that's the aim of my research. Talking about computational fluid dynamics, it is basically mimicking the actual fluid flow experiments that are done in the laboratories using some mathematical tools. Conventionally, it consists of three different steps. The first step is called geometric creation, in which we create the geometry. The geometry can be as simple as a cylinder or can be as complex as an actual aircraft. The second step is called meshing, which is nothing but dividing the area into smaller ones, keeping in mind the shape and size of the geometry. The third step is in which we use mathematical tools to get the numbers which is quite close to the experimental ones. Out of these three, the meshing is the most critical and the most time-consuming step. It is said that in early career, a fluid dynamics engineer spends almost half of his time in creating a good quality mesh. And there is a famous joke in the industry that once you create a good quality mesh on the first day of your job, you'll end up in doing that for the rest of your life. So meshing being that important, why not simply remove it? Or why not just reduce the dependency of the quality of the result obtained on the quality of the mesh created? So the aim of my research is to reduce this dependency. Well, there is an old saying, if you want to reduce your dependency on something, start your life without it. So what I did is I first created a mesh, the simplest mesh possible, not the geometry as we used to do earlier, and then I created the object. The main difference is that I created the mesh without knowing the shape and size of the object. So once I have these two things, I will use my mathematical tool to generate the results which are quite close to the experimental one. So when the first time I saw my result, it made my day. The results which I get are not only close to the experimental ones, but also saves a lot of time, simulation cost, as well as energy. Thank you.